This is the sequences and series question that came up in 2017, part B. So the square has sides of length 2 centimeters, and then the midpoints of the sides of the square are joined together to form another square. So this side is halved, and then the midpoints join and form another square. And then this process is continued. So the first 3 squares are shown, so they give us this diagram here. Then it says find the sum of the perimeters of the square if this process is continued indefinitely. So we're looking for the sum of the perimeter of the first square, the perimeter of the perimeter of square number 1, the outside square, plus the perimeter of square number 2, square 2, plus perimeter of square 3, until we get the perimeter of up to the perimeter of the last square, the perimeter of final square. That will work. So we're looking for the sum of the perimeter of the first square plus the second plus the third all the way up to infinity. So this looks like the sum up to infinity. So we could check that we know from our log tables that the sum of a geometric series is equal to a over 1 minus r. That's the sum to infinity of a geometric series. And if we want but we can only do this if it's a geometric series. So first, to show that it's a geometric series, it must have a common ratio between each of the terms. It must have a constant common ratio between each term. And then if we're going to use a sum to infinity, if we're going to use this equation, we're going to have to show that the ratio is greater than a minus 1 and less than 1. So basically the absolute value of the ratio has to be less than 1. So we can't just plug it in here. We have to check, is it a geometric series first, get the ratio, and then we have to show that the ratio is less than 1. So let's do that first. So first we're going to have to, they didn't ask us, so I'm going to write out the side. So they didn't ask us for a series showing the sides. They asked for a series showing the perimeter. So the sides of 1, 2, and 3. And then I'll work with these. So the first square, which is the outer square, the sides are 2 centimeters. So the perimeter is going to be 2 by 4. So it's going to be 8. So the sides are 2 and the perimeter is 8. And then the next square, we were told that the next square was formed by joining the midpoints of the square before it. So this midpoint from here to here will be 1 because the altogether is 2, and from here to here will be 1. Similarly, from here to here will be 1. But this is a right angled triangle. So if we're looking for this length here, if we want to get this, we can do 1 squared plus 1 squared is equal to this squared. So let's just call that x for now. So the square root of 1 squared plus 1 squared is equal to x, and that's root 2 is equal to x. So the next length square has sides of length root 2. So I'm going to plug that in. So the sides are root 2, so that means the perimeter will be 4 root 2. And then I have to deal with the next square. So this square here was the corner was formed by, so say if I want to deal with this triangle, the corner will be halfway through the line. So this side here, from here to here, is going to be 2 root 2, and similarly from here to here, from this point to this point, is going to be 2 root 2. So say if this was our right angle triangle, so 2 root 2, so say if we were to have that like as a triangle, so it'd be 2 root 2, root 2 over 2 over root 2 over 2, because I'm having the root 2 because it's a midpoint. And then say if you want to find this length of this here, we could use Pythagoras, so it would be root 2 over 2 squared plus root 2 over 2 squared is equal to x squared. Let's just call this x for now, and then work that out. So root 2, so that'll be 2 over 4 plus 2 over 4 is equal to x squared. And then 2 over 4 plus 2 over 4 is 4 over 4, which is 1, is equal to x squared. And then the square root of 1 will just be equal to 1. So x is equal to 1. X is equal to 1. So now we've established that the side of the third one has sides of 1. So then the perimeter will be 4. So now I'm going to look at the ratios between each of these to see if there's a common ratio between all of them. So I'm going to put this term over that and get the ratio. So it's 4 over 2 over 8. So that's going to be root 2 over 2. Now I'm going to look at my second, this over this. So it's going to be 4 over 4 root 2, and that's going to be 1 over root 2. And if I wanted to change that and have my root 2 on the top to see if it was the same as this, I could just plug it into my calculator and see that they are the same values. But what I'll do is I'll just multiply above and below by root 2, and then I'll be left with root 2 over 2, and they are the same value. So we've established that is so it has there's a common ratio, so it's a geometric series. But root 2 over 2, if you want to plug it into your calculator to check, root 2 over 2 is less than 1. So the ratio is less than 1, so we can use our formula here. So I'm just going to go on to another page so we have a bit more room. So we've established that our series is, so for the perimeter, so we're dealing with perimeter, not sides. So the perimeter of the first one is 8, then 4 root 2, then 4. So first one of the second term and the third square. And our ratio that we've just gotten is equal to the term and a term over the term before it, and then which we got root 2 over 2. So, and our formula, which is in your log tables, is a minus 1, and a over 1 minus or. And if we're to use that, we have to establish that it was geometric and that the ratio was less than 1, which we did establish there. So I'm going to plug my terms. So firstly, a is equal to the first term. So our first term is 8. So it'll be 8 over 1 minus root 2 over 2. So I could just plug this into my calculator and my calculator will do the work for me. Or if I want to do it out myself, I might want to get rid of my 2 on the bottom. So if I multiply everything by 2, so it'd be 16 over 2 minus root 2. But I kind of want to get rid of my cert on the bottom because that's not the format they asked for. They asked it for, the format they wanted was a plus b root c. They didn't want any fractions. So I'm going to have to multiply by the conjugate of 2 minus root 2, which would be 2 plus root 2. So that's just, it's not changing the fraction because you're multiplying by the same term on the top and the bottom. So that's going to be 16 by 2, which would be 32 plus 16 root 2. And then 2 by 2 is 4. 2 by root 2 is plus 2 root 2 minus 2 root 2. And then we'll get minus 2. So if you multiply any third by its conjugate, so it's just here it has a minus in between these two terms, and we just left a plus. But if you don't want to have to do that, you can just plug that into your calculator, or this even into your calculator, and it'll do the work for you. I just thought that I might do it out for people that might want to do it themselves. So then we have 32 plus 16 root 2. The purpose of multiplying by the conjugate is to get rid of the square root. So we're gonna, these will cancel, and then it's going to be over 2. So, but we didn't want fractions in our answer, so 16 plus 8 root 2. And that is the format that they wanted it and they asked for in our question. So that is our answer. Thank you.